Okay, let's embark on this deep dive into Azerbaijan's hydrometeorological situation. We're looking specifically at the next 10 days, that's October 20th to the 29th, 2025, and also sketching out the bigger picture for the winter of 2025-2026.
And we should probably jump right in because the immediate story is one of, well, divergence, a real split.
A split, how so?
Well, if you're in Baku or the Absheron Peninsula, things look pretty stable, relatively dry for most of the coming week. But, and this is important, the northern and western regions, they have an immediate advisory tonight, Monday, October 20th.
An advisory for what exactly?
Severe convective weather.
Okay, severe convective weather. For listeners, what does that actually mean on the ground?
It means you could see really rapid storm development. Think sudden heavy thunderstorms, maybe some hail, and definitely strong gusty winds that can pop up almost out of nowhere. That's the immediate concern, the high priority one for tonight.
Got it. Intense and sudden. But that instability doesn't stay away from the capital forever, does it? Our sources suggest Baku stays calm, mostly until Wednesday the 29th.
That's right. October 29th looks like the turning point for Baku. A low-pressure system moves in. You're looking at stronger winds then, potentially gusting up to around 48 kilometers per hour, and some isolated thunderstorms too.
So the end of that calm, early autumn feel?
Definitely. And that 48 kph wind forecast for the 29th, that's significant, especially thinking about the Caspian Sea.
Ah, because of the potential for high waves?
Exactly. We know from historical data that even winds at that speed, coming from the northwest typically, can whip up waves over 5 meters high on the Caspian. So any marine operations, coastal areas, they need to be really watchful around that.
And there's another angle here, isn't there? This ties into the longer-term climate picture, the shrinking Caspian.
Yes, it's a really stark connection. As the Caspian sea level drops, huge areas of the former seabed are exposed.
Right, miles of it.
So when you get these strong winds like the ones forecast for the 29th, it's not just about the waves anymore.
Yeah.
The wind picks up salt, fine sediment, all that dust from the exposed bed.
Turning it into dust storms.
Precisely. Dust storms impacting air quality, public health. It's a clear example of, long-term climate change, the sea shrinking directly, making short-term weather events more hazardous.
A worrying feedback loop. Okay, let's pivot slightly to the mountains. The Greater Caucasus. What's the timing there? Still above freezing for a bit longer.
Yes, temperatures should stay above freezing up there until about the 29th as well. But the change is imminent. The models are pointing pretty clearly now.
To the first snowfall.
Expect the first proper seasonal snowfall, maybe 1 to 4 centimeters, right around Friday, October 31st. It signals a really rapid shift at altitude from autumn straight into, well, early winter conditions.
Okay, so we have these immediate risks, the regional split, the wind, the coming snow. Let's zoom out. The sources highlight some, frankly, shocking long-term shifts in the baseline climate.
They really do. And it seems almost paradoxical at first glance.
You mean the fact that there's been a documented 6-fold increase in the intensity of rainfall events?
Right, 6-fold. Much heavier downpours when it does rain. But this is happening alongside an overall trend towards a more arid climate. Drought risk is projected to soar.
Soaring drought risk, but heavier rain. How does that work?
It's all about volatility in the water cycle. Think longer, hotter, dry spells, baking the ground hard. So when the rain finally comes, and it comes in these intense bursts, the ground can't absorb it.
It just runs off.
Massively, leading to immediate dangerous flash floods. The baked soil basically acts like concrete. That's the crucial link.
Understood. So looking ahead to the winter of 2025-2026, based on this context, the main threat isn't necessarily just prolonged cold, is it? It's this volatility again.
Exactly. Extreme swings. And the global drivers seem to be primarily a weak La Nina pattern in the Pacific, combined with an unstable polar vortex.
The polar vortex. That's the band of strong winds high up that usually keeps the coldest air locked over the Arctic.
That's the one. When it's unstable, it can wobble, weaken, even split. And that allows chunks of very cold Arctic air to plunge much further south than usual, leading to sudden, deep freezes.
And the data connects this instability to something called the quasi-biennial oscillation, the QBO, being in an easterly phase, affecting stratospheric winds.
Correct. It's a complex interplay of factors, but the bottom line points towards a winter with potentially dramatic swings in temperature and precipitation. Not steady cold, but periods of intense winter weather, followed by possibly rapid warming.
And that leads directly to the most dangerous scenario, the compound hazard.
Absolutely. That's the real worry. You get periods of heavy snowfall, building up a significant snowpack, especially in the mountains. Then a rapid thaw sets in.
Which on frozen ground
Means meltwater can't soak in. It runs off incredibly fast, causing severe flash floods in the lowlands. At the same time, that heavy, wet, unstable snowpack in the mountains is primed for avalanches.
So emergency services could be facing both major flooding and major avalanches simultaneously.
Precisely. A compound disaster. Interconnected events, overwhelming response capacity. That's the critical risk stemming from this predicted volatility.
That's a truly sobering prospect. Which brings us to a final thought, something for you, the listener, to consider. We've heard about the increasing intensity of rain, the drought, the volatility, these dangerous compound hazards. What does it mean, then, when our sources also document that Azerbaijan's current national hydrometeorological network is considered insufficient? Given everything we've discussed, doesn't that finding make the need to urgently upgrade monitoring, forecasting, and especially those early warning systems not just important, but absolutely essential for resilience? Seems unavoidable, really.